Hello, my friend, and welcome in this new recording. This is my devlog session number 28 already, and today we're going to talk about the full physically based rendering workflow where you have support for image-based lighting, and also you use appropriate textures to control the different aspects of the material. So the roughness, metallicness, the metallic aspect, albedo, and so on. This is going to be mostly based on the previous session that we did, where we introduced support for the IBL part of the workflow. And it should be relatively simple compared to the previous one, which is going to have a few textures in the shader itself. But we're going to cover different points before that. And so let's switch to the article that I have. It is. So we're going to start with some optimization of how we're going to process the PBR generation in general. Then we see how I loaded the Cerberus model, which is the one that we are going to focus on here, and this required a small change in my loading process. Then we're going to actually add the textures in the shader, probably the most important part here. And we will finish with some changes on the IM-GUI interface to be able to change the environment map for the display of this model. So before we jump into this, as I did last time, I'm going to show you what is the currently result that we get. So this is a Cerberus model, some kind of gun, and so we now have all the textures loaded on this model, plus the lighting effect coming from the environment. And we have the ability in this small example to move around the model and also to change what is the current environment. So I can switch to this one, for instance, and you see that the model itself, the lighting is changing significantly because the environment map and the irradiance map is changed. So yeah, basically this is it. Let's just see now how we reach this point. The example code is in this file, the PBR texture file. And as I said, the first step that I took was to try to simplify the implementation of this example compared to what we have in the previous one, which is a PBR IBL. So you see this one, for instance, is 450 lines. In this one, I think it's already shorter. Yep, not even 200 lines. How did we do that? I simply tried to encapsulate everything related to the PBR generation in dedicated functions, in fact. So in the engine, in fact, I have now a new PBR utils file. And you see that in this one, we have a dedicated function to generate the BRDF lookup table. And if you think about it, this lookup table, which we were generating previously here in the generate BRDF load, this one actually doesn't depend on anything. You can just provide this render pass in empty texture, and it's going to generate the BRDF using simply some calculation in the shader. So this is something you can do, in fact, just once, and you can reuse this for as many PBR environment or PBR processing that you want. And so that's the idea with this function. In fact, we are currently caching the RDF texture in the engine itself. So we call that in the engine class, maybe not just here, but here. So when you're requesting access to the this texture, it's first going to check if the texture already exists, and if it's not the case, it's going to generate that, but it's going to do that only once, and then you don't need to do it again, and you can just call this function every time you need to access this BRDF lookup table. The only thing maybe is I don't know, maybe there would be cases where you would want to have different size for this texture. By default, I think the size is 512. Yes, it is. But I'm just starting on that, so I have no idea if it makes sense in some cases to change this resolution. And for now, I'm just going to assume that it's not the case. And otherwise, you could just call the base function here and cache the result somewhere else. So yeah, not much to say about that, except also maybe here I'm again not registering this render pass in the engine, which means that you are going to create this render pass here with a reference on it. You're going to request a rendering of 6 points with this shader. We also have support for just executing a render pass now, so it's still using the engine and the command builder under the hood, but it's encapsulating all that. It's just executing a single pass, and you just retrieve the output from this render pass. And after that, the render pass itself is going to be destroyed and discarded. So you're just not caching anything here, not keeping anything in memory when you're done, which is, I think, a better option. Okay, and so we did the same thing for the two other functions. So the two other parts of the PBR, the generation of the irradiance cube map here. But this one, you will need to start with the actual environment map that you want for this this IBL environment. So to generate the irradiance, you need your actual environment map, and then you can proceed as what we did in the PBR IBL. Generate irradiance, so basically add the same code as what we have here. A bit cleaner maybe. And also we have this dedicated function now to retrieve the cube map model view projection matrices as a uniform buffer like that. But apart from that, yeah, not much more to say, except again that, yeah, we're just creating the render pass here, executing that. And when we're done executing that, we just discard this object, so not caching that, not keeping that in memory. And same thing for the filtered environment map. Same process. We just have this additional pass data, and yeah, doing the rendering once and discarding the render pass. Okay, and on top of that, I have also added a function here, which is putting those three functions together. And you can just make a request to say, basically, you want to create the IBL context for a given environment map, and it's going to provide you with the BRDF, the irradiance, and the pre-filtered textures. So this is what we have, in fact, in this structure, those three textures. And when you call that, you provide some information on how you want to generate this IBL context. And so you just either provide directly the environment map, or you can just provide a name pointing to a file, or maybe not exactly a file, but yeah, I have a mechanism to be able to load multiple files to create a cube map based on some kind of prefix, and just adding the suffix that you need for the different files. the different spaces. You can also still customize the size that you want and also the usage that you want for this for the generated textures. We'll come back to that. It's going to the usage here is going to apply to the irradiance and the pre-filtered environment maps, and we'll come back to that to explain why you actually need that here. So when we use that now, we can just remove those pre-construction functions from the simple code, and so we're not going to look at construct GUI, but in setup app, we have now called this function generate PBR IBL context, and we provide a simple name, which is giving us a cube map texture here, and the usage that we want is texture binding and copy destination, and it's going also to automatically add the render attachment usage, because when you call that, it's going to render to those textures anyway. So automatically add this part of the usage. Okay, apart from that, what else did we change? I think we have covered for now the first point. Now let's just get to the loading of the Cerberus model. So we were at some point trying to load the Cerberus model here. This one is a bit more complete than the other ones we've tried this so far, because it's providing also the tangent as a vertex attribute here. So that's why we have this T. So information, position, normal, tangent, oops, and UV0. And we're going to use this tangent information because we also have a texture for the normal mapping in this context. But what was not working when I tried that was in the loading itself of the GLDF model. So let's have a look at that. I'm not sure where this is anymore. Let me just refer to the code maybe. So we've seen the first part here with different functions. Oh, another thing I tried also was to simplify a bit the bind group that I was providing initially for those two simple models, the sphere and the teapot, because the reference implementation was using one simpler paired texture, but in fact it was the same kind of simpler, linear simpler for all of them. So you can just use a single one and share the simpler for all the texture that you're going to symbol in the shader. So this is what we did. Instead of repeating bind linear shader multiple times, we only have one now. Okay, and so yeah, first thing I noticed is that when you load the GLDF model, I was so far expecting that the parent nodes would be described before any kind of child node. So you would expect to have node 0 always be in the parent position compared to another node. So you could have later maybe node 5 pointing to parent 0. But it's not true. You can actually have node 0 pointing to parent node 1, which is coming after. So you have not yet actually loaded this node 1 and you still want to access that. I mean, at least in the implementation that I have. So I had to increase the flexibility on that, and when I find a parent which is still missing, I just try to load that immediately. So yeah, avoiding a crash here. Then yes, the issue that I had was that I knew that there was some kind of limitation on how you can write to the buffers in the web GPU. First, there's this very large alignment request of 256 bytes if you want to use a buffer with a dynamic offset. So the different position that you want to use for the change of the dynamic offset have to be aligned on 256 bytes. But there is also another limitation, which is that when you want to write to a buffer, you have to write data which is of the size of multiple of 4. And I thought this would apply only for buffer that would be used for uniform binding or storage binding maybe, but it's also true for buffers that are indices, so index buffers, and probably also true for vertex buffers when you think about it. And the thing is, for index buffers, there can be cases where you have indices that are in integer 16 format, so taking 2 bytes per index, and you could have a number of indices that is not a multiple of 4. I mean, the number of bytes could not be a multiple of 4. And so I had to somehow fix that when I'm loading the GLDF model. So the buffer that I'm creating to contain the actual data would sometimes be increased a little bit. I'm not sure how I was doing that exactly. Let's try to find that. To get a bit of context. No, not here. So the GLDF model, you're going to compute the alignment size for your buffer, for your index buffer size. Okay. So you compute the real size that you want, and then you try to align that on 4 bytes. If it's not the same value, just put output a message, and then you use this align size to create your vector. Okay, and your vector will in the end contain only 0. So at the end of the vector, you may still have a couple of zeros that you're not writing to, but in theory, since you know what is the number of indices that you want to use, you're never going to request to use those out of range values. I mean, those. The only case is you would have one out of range value because, yeah, if you're not aligned on 4, you are at least aligned on 2 because these are in the 16s values. So if you just add 2, you would be aligned on 4 in theory. Yes, that's it. Okay, not much more to say about this one. Next, yes, we started to actually add the textures in the shader. So let's have a look at this one. This one is a interesting part, I guess, because so we have this PBR texture GLSL file now, which is pretty similar to the previous one. So the PREF, IDL, GLSL, or maybe version 2, because as I said, I have been reworking a little bit how we are providing the sampler. So we now have a single sampler here shared with all those textures. So that's that was the initial performance version in this case. And for the texture version, what we did was to simply provide additional textures here. So you see we're starting to have quite a few of them, in fact. And yeah, let's see where we actually use, for instance, this one. This one, you're going to have a dedicated function to get the albedo, which is going to call the sampling here. And get albedo is something that we do only once in the main fragment code here to get this value. And in fact, in the previous version, this is the value we're simply reading from the material uniform buffer that was provided. And it was a fixed color. And now it's something that is changing depending on the current location, the current UV that you have in your texture. But apart from that, you're just going to use this vector in this case here and there's another location, I think, a bit above. Yes, here we were actually using this color again, but this will be replaced by the albedo in the updated function here. Calculate normal, that's coming after. Where is it? Yeah, albedo is here. So I actually also now decided to provide this spec3 as a parameter for the specular contribution function, so that we don't need to call get albedo another time. So that is removing one texture sampling call. Okay, same thing for the roughness and metallic aspect. Before that, in the previous version, these were simple float value that were read directly from the material uniform buffer. But now we have UV coordinates, and we're going to sample the corresponding textures at this location, and we just read the red channel, or the first channel if you want, to get the corresponding plot value. And that's the only location where we retrieve those values, and then we can use them at different location again. Okay, what else was there? The other two elements, so the normal map and the ambient occlusion map, those are not really part of what we did previously on the image-based lighting context. But you can still use your normal map to improve the normal that you're going to use in the process. So this is what we do here, in fact. Instead of using the normal vector, which is provided as input in the fragment shader, you're going to compute the actual normal based on the normal map that you have. So you do the sampling here, and you get the local vertical and local tangent to build your reference matrix and get the normal in this local reference frame. Again, yeah, we're just calling that once, producing this n vector, and then we're going to use this in n vector at different locations. So here, for instance, here also, and again, once here. And I think that's it. And for the ambient occlusion, it's the same thing. We're going to use that only once when we're computing the ambient. So before, for the ambient, we're just using this, and we have yeah, this line, in fact, in the reference IBL version. So this is going to be to define your ambient contribution. But when you have the occlusion, ambient occlusion map, you can simply multiply that by a factor which is read from the ambient occlusion texture for your current UV coordinates, and that's it. So yeah, with that we got all the additional texture integrated into the process. On the C++ side, the shader itself, the render node itself is not much more complex. It's just that we are now just loading those additional textures. On the long run, of course, that's something I'm going to improve on. You don't want to have one dedicated texture for each of those sources, because you could actually put all of them in, I mean, 4 of them at least, in a single texture. Well, normal map will be a bit more tricky, so you need to keep that separated, I guess. But for roughness, I mean, albedo also because you're using those 3 channels. But you can put together roughness, metallic, and ambient occlusion. I'm not sure how this is done really in production, so we'll check that eventually. Anyway, this is for the introduction of the additional texture. The final part that we did was to provide support to be able to change the IBL context, so the environment mapping, dynamically. And to do that, the logic that I took was to first set up everything in the application with a fixed IBL context. And this IBL context is going to point to 3 specific textures. BRDF, irradiance, and pre-filtered environment cube maps. So, and those textures, you are going to first use the filtered environment to construct your skybox, and also then reuse those three textures to use them in your bind group. So if you want to change this environment context and you already have a bind group pipeline constructed, if you wanted to change the actual texture, you would need to build another bind group and rebuild the pipeline. I mean, not rebuilding the pipeline, but at least rebuilding the render bundle. So I thought, okay, maybe you don't actually need to do that, because if you know that you have the texture on the GPU, what you could also do, and I believe this is cheaper, is to load your IBL context somewhere else in a different texture, and then simply copy your different texture into the texture that you are using for the pipeline rendering. So this is what we do with the GUI that we have provided now for changing the environment. So again, in the construct GUI function. So in there, we can provide a list of currently simply 3 different environments. And we are going to keep, in fact, in the example class, a mapping of IBL context that are already loaded. And what we do is whenever we detect a change in the required environment, what we check is whether this IBL context is already created. So whether the triple of the 3 textures were already loaded. And if it's not the case, you're going to simply generate this IBL context using the appropriate environment map. And that's where you actually need to mention that, okay, you want to be able to copy from the irradiance and pre-filtered environment textures that you are generating right here. And for the main IBL context that you use for the actual rendering, as you can see here, what we said was that we want to be able to copy into those textures. So the first time we're going to execute this part, you're going to render into those textures. But then if you want to change the content of those textures, you're going to copy into those textures from another existing texture. And so that is what we do now, because once you have checked that this environment is existing, you just retrieve that, and you have now a dedicated function here, copy texture to texture, which is going to take your source irradiance and copy that into the destination, and same thing for the filtered environment. So what this function is going to do is based on the main copy texture to texture function that you have in the command encoder class from web GPU, but this one actually is going to copy a single map level. So what we want to do here is in fact copy all the map levels, because we're just assuming here that the textures are exactly equivalent. And they have the same number of map levels, the same dimensions, and you can vary the same format, and you can copy the content from one into the other without any kind of issue. So this is what we do here in the case that the map level specified as argument is -1. And yeah, that's basically what you need. When you submit that, then on the next frame, you get your updated IBL context. And I think this is it, because apart from that, not much more has changed. One thing through is we're still relying on a PBR material uniform buffer, but if you think about it, we're not even using that anymore. So in the shader, we have this PBR material but we're not using any of this. So eventually I could remove that, but I'm not absolutely sure about this because there might be cases where you want to build a PBR context, still using, for instance, simple color vector for the albedo, and you don't want to use a texture for this slot. So you might want to build some kind of combination between simple vectors and textures. So maybe you still need some kind of structure like that. But yeah, for now, not used. Anyway, so yeah, 30 minutes, we're done. And I hope you learned something on this recording. And yeah, thanks for watching. As usual, happy coding on your side. And if you have any question and you want to discuss anything, just let me know in the comments. And see you next time. Bye bye.